In this lesson, we will answer the following question. What is the relationship between central angles and inscribed angles in a circle? Since this theorem involves inscribed angles, it's helpful to remind ourselves what an inscribed angle is. So if I have a circle, an inscribed angle is an angle whose vertex is on the circle and whose endpoints are also on the circle, like this. So angle ADB would be an example of an inscribed angle. Now, the inscribed angle theorem says that the measure of an inscribed angle is half the measure of its intercepted arc. So notice that the inscribed angle ADB intercepts the arc AB. According to this theorem, the measure of angle ADB is going to be precisely half the measure of arc AB. We're going to use this fact to solve the following problem. We want to find the measure of arc BC, the measure of arc BD, the measure of angle DAB, and the measure of angle ABC. First, we're going to find the measure of arc BC. Now, according to the inscribed angle theorem, the measure of angle BAC is exactly half the measure of arc BC. If I multiply both sides of this equation by 2, I get the following, that twice the measure of angle BAC is equal to the measure of BC, which makes sense. Of course, we know the measure of angle BAC, it's 31 degrees. So that means that the measure of arc BC has to be twice that amount. Okay? So the measure of arc BC, along with its central angle, is 62 degrees. Now, by the arc addition postulate, I know that the measure of arc BD is equal to the measure of arc BC plus the measure of arc CD. But I just calculated the measure of arc BC, and they've given me the measure of arc CD. So the measure of the entire arc is just the sum of its parts, BC and CD. So BC is 62 degrees, and CD is 88. Therefore, we get the measure of arc BD is 150 degrees. Also, by the inscribed angle theorem, I know that the measure of angle DAB is exactly half the measure of arc BD. So the measure of this angle DAB is half of 150 degrees, which we calculated here, which is 75 degrees. So the measure of angle DAB is 75 degrees. To find the measure of angle ABC, note that arc ADC is a semicircle. Therefore, the measure of arc ADC is exactly 180 degrees, since it's a semicircle. And by the inscribed angle theorem, notice that angle ABC, the inscribed angle, intercepts this arc. But the inscribed angle theorem tells us that the measure of this angle here is exactly half of the measure of this arc. So that means that the measure of angle ABC has to be 90 degrees. Alright, so the following theorem we're going to talk about here describes a key relationship between inscribed angles and diameters. The endpoints of a diameter lie on an inscribed angle if and only if the inscribed angle is a right angle. Okay. So this means that if I have an angle that's inscribed like this, that touches or intercepts a semicircle which measures 180 degrees, then the inscribed angle theorem tells us that the measure of this angle has to be 90. Since the measure of this arc is 180 degrees. Another theorem that relies on the inscribed angle theorem in its proof is the inscribed quadrilateral theorem. It's a theorem about the measure of the angles in any quadrilateral that's inscribed in a circle. Now, if a quadrilateral is inscribed inside a circle, according to the quadrilateral theorem, then its opposite angles are supplementary. The converse of this is also true. Taken together, the theorem and its converse tell us that a quadrilateral can be inscribed in a circle if and only if its opposite angles are supplementary. Now let's give a proof of this fact. Suppose that we're given a quadrilateral ABCD that is inscribed in a circle O. We want to prove that opposite angles are supplementary. That is, we want to prove that angle A and angle C are supplementary and angles B and D are supplementary. Well, arcs BCD and arc DAB make a complete circle. Therefore, the sum of those two arcs has to be 360 degrees. Now notice that angle A is an inscribed angle and its intercepted arc is BCD. Also notice that angle C is an inscribed angle and its intercepted arc is arc DAB. By the inscribed angle theorem then, the measure of angle A is exactly half of its intercepted arc, and the measure of angle C is exactly half of its intercepted arc. Now if I substitute this in, I know that the measure of angle A plus the measure of angle C has to be equal to 1/2 the measure of arc BCD plus 1/2 the measure of arc DAB. And this is just substituting in from the previous facts here. Now, using the distributive property, I can factor out this 1/2. And also, knowing that the measure of arc BCD and DAB, when added together, form a complete circle, therefore the sum of these two arcs has to be 360 degrees. But half of 360 degrees is 180 degrees. So we've just shown that the sum of angle A and the sum of the measure of angle C is 180 degrees, or in other words, those angles are supplementary. Similar reasoning shows that angles B and D are supplementary. Alright, so in this lesson we address the following question. What's the relationship between central angles and inscribed angles in a circle? Well, the measure of an inscribed angle is exactly half the measure of its intercepted arc. The measure of the arc is equal to the measure of its central angle for minor arcs, or 360 degrees minus the measure of its central angle for major arcs.